So when you were starting Rivet, when y'all applied to YC, the sort of theme was sort of infrastructure for games, for like multiplayer games. That seemed to be sort of the pitch. It's like we're gonna make it easy for game developers to build multiplayer experiences. But it seems now you've transitioned to more of a general purpose computing platform. Can you walk us through sort of what the transition from pitching YC to like where you're at today?
Yeah, for sure. So coming off working on Prugger and a bunch of other .io games, like I've had my fingers in most big .io games like dev.io and a bunch of other like mob.io and stuff like that in some way, shape, or form. And so through doing that, it was really easy to start a gaming infrastructure company because I was doing what I was effectively doing as a consultant, and now just transitioning that into a product of seeing the problems I've seen over and over again. And those problems in gaming are very straightforward. It's like you need servers that are high performance, low latency, and don't get shut off randomly. And so that also requires things like UDP, which a lot of platforms surprisingly don't support. And the most important part is like the elasticity. So if you have a surge of players, you need to make sure those players aren't getting turned away. Most games have downtime when they launch, which is their most important time. So that was our focus. And we were very focused on like running like Unity builds, dropping in a container, being able to scale up on the cloud and being able to do it in your own cloud and stuff like that. Over time, we started getting more and more people asking for similar use cases outside of gaming. This idea of like having stateful compute is what we call it. So anything where you have like a unit code that needs to be running to do something, such as a real-time, like think about like a real-time whiteboard. Like you need to have some unit code that is actually like processing the logic for that. We got more and more clients kind of asking for that type of thing. And so eventually we started looking at like, where should we be focusing our effort? And I guess in parallel, we'd also spend a lot of time working at gaming services, and we had built a lot of technology on top of Redis. I don't know how deep you've gone into Redis, but we were writing these crazy like multi-thousand line Lua scripts and running it on a Redis instance to get like complex real-time logic on Redis. At that point, I had tried like an earlier version of durable objects, Cloudflare's durable objects, which seemed to be like a much more mature alternative to this. And I mean, it was crazy, just like migrating thousands of lines of Lua to like a couple hundred lines of code and being faster and getting edge support and all this other stuff out of the box. So it's kind of a combination of like being durable object build, if you will, and also having more and more people asking for something like durable objects, but open source and on-premise. That was kind of obvious to shift what we had built in gaming and actually make it more generalized for other applications. And so out of that came what's called Rivet Actors, which is built on the same like really high performance tech that we built for gaming, but for general applications.
So in that transition, did like the API just change completely, or were there still like the smatterings of the current API back then?
Yeah, it was really funny doing the API migration because if you look in the cloud, you'd see like project, what we call namespaces, and then what we called actors. But like on the API out of the hood, you would have games, and then you'd like game namespaces, and then like there's all these like gaming specific terminology. But eventually we started adding aliases to like not make us you're calling like, why am I creating a game server? It's like, I don't know what a game server is. With our V2, we have like a clean API slate, and everything is called an actor under the hood. Yeah. But in terms of actual like support, like a lot of it there was a lot of overlap. One of the interesting components, which I'll go deep on some of the info stuff. One of the interesting components is what we call Rivet Guard, is like this, it's effectively a mesh network that handles all the traffic routing through the Rivet backbone. So we try and abstract it from you completely. Like you don't know that there's any fancy networking going on under the hood. But when you run a container on Rivet, you need to have a bunch of extra things like DDoS mitigation. How do you handle things like container migrations? How do you handle like downtime of containers? How do you handle like surge traffic? There's a lot of other edge cases, like say you send a bunch of requests to a bunch of actors, you need to be able to spin up those actors in demand. But if those aren't running yet, then that request is going to fail. So Rivet Guard just acts as like this magic thing that runs behind the hood that was really important in gaming and is now also very important for what we're doing now.
Maybe it'd be a good time to take a step back and talk about what Rivet is building. So as I understand it, you have two main like compute products. You have container service. So it's like you're running like Docker containers or something similar. And then you have this like actor framework and actor service. So actor, like the Erlang actors, if folks are familiar with that, or like durable objects if people have heard about it. So can you kind of describe more of like what an actor is in this context and what it looks like in your product?
For sure. Yeah, I'm definitely getting in the weeds here a lot. High level, we call ourselves a stateful compute platform. What we consider stateful compute is anything that needs to be like long running or has real time or has like durable state. And so under that definition, you have something by more like actors, which is, I'll get to that, and then like containers of just like a straight up like Docker container. The most basic concept of what we call an actor is like, hold on, let me run a bit. We're very focused on the idea of like actors, of like an actor basically has a start and a stop and it can go to sleep. And so, for example, if you're running an AI agent, the user will process a command or some event happens and the agent needs to take a step. It's going to wake up, process that step, sit and wait for some more commands for a bit, and then go to sleep. And during that process, you can actually do things like do a bunch of real-time connections, open WebSockets, publish messages to other things. A lot of really interesting logic. And if you extend that to containers, it's a lot of the same logic of like a container has a start and a stop and some form of persistence being the file system. So naturally, it all kind of fits together. And when you start gluing that together, it gets really interesting because you could start doing things like having your brains and your Rivet actor. So this is like what's going to be orchestrating all of the agentic logic, and then attach a container to do things like running arbitrary like Node.js processes or something like that, like secure things. And when you put those two together, it's a really interesting pattern that there's a lot of people building use cases around those technologies nowadays.
Okay, so you started in the gaming world and you're sort of like building this platform with containers and actors. Have your existing customers, if you still have like folks who are like building with you in the beginning, have they moved over? Are you seeing like people using the tools that you've built to like make games? And I'm just curious of like what sort of like use cases have come out of that and how that's pushed or your prioritization for what you build.
For sure. Yeah. Yeah. We still have a lot of gaming customers. We can make sure that they're still able to be served by the current platform. But the use cases it's very similar. And I think it's really important to root how we build our technology. Like if it's not, we build everything we build to be fast enough for a game. And so if it's fast enough for a game, it's probably fast enough for everything else. And it's going to probably be cheaper and way more efficient. And so everything down to like the way we do binary coding, the way we do like network traffic, the core is written entirely in Rust. All that stuff is very, very hyper optimized so that you can build a game. And I think that's especially in the world of JavaScript. Like I think it's good to have like really good core and then put the logic in JavaScript. And so I hope that as people try Rivet, they'll see that performance in practice.
Yeah. So my question is getting towards the Cloudflare of it all. In your guys' Y Combinator page, like your byline is open source Cloudflare workers and durable objects. That seems to be different than what we've talked about so far. We've talked about an actor framework. If I go through your homepage, I can see like you support many different backends. So like including durable objects. So like where does that come from? Are you guys re-implementing a lot of what those other services do so it works with all the services? Like, how does that shake out?
For sure. Yeah, we're very focused on like the Rivet actors or like an open source durable objects alternative, to the point where like we think we built some really cool features that can actually run on top of durable objects. I've used durable objects so many times. I just know the things that you write over and over again. And so those features apply to durable objects, but also apply to all other platforms. But one really important thing that is especially in our Rivet V2 launch that we find really important is actually the flexibility of your infrastructure. When we launched our V1 back in January for Rivet actors, we kind of mirrored like the Cloudflare architecture of Rivet as a platform where you deploy your JavaScript code, and we have our own V8 isolate platform that runs your code inside of our stuff. And then we have all sorts of optimizations to scale up. The problem is that what you're asking people to do when you're doing that is to really bend over backwards to support your platform. Most people have everything in Kubernetes or their own cloud of choice like Railway or AWS or whatever, and private networking. And so it just becomes really difficult for people to adopt. And so the options are either like create like all sorts of security issues with running your code externally from your infrastructure, or try and run all Rivet internally on your infrastructure. So now Rivet V2 is actually a little more, it's much more lightweight if we don't actually run your code on top of Rivet. What we do is Rivet is a bit more, you can think of like more like Kafka, where it's a service that orchestrates everything that's connected to it, but you can connect what we call runners to Rivet from anywhere. So that lets us support platforms like Railway, like Kubernetes. We have Vercel coming very, very soon. I don't want to put a timeline on that just yet. in serverless platforms. And I mean, just like seeing the responses after V2 and the amount of people who are actually like tourists as opposed to like actually getting something real running just over the past week. We launched 8 days ago now. Is pretty impressive. And I'm really glad that we made this shift, even though it was like a lot of work on our end to rework it, but I'm happy that's happening.